First thing I need to tell you about in this video about vectors is what the difference is between a vector and a scalar measurement. So with a vector measurement, it has size, but it also has an element that tells you the direction. Whereas with a scalar, it's all just about the size. So some common differences between scalars and vectors. So for example, speed is a scalar unit of measurement and its vector equivalent is velocity. So the difference between these two is speed is just how fast you're going, but velocity is not just how fast you're going, but in what direction you're going as well. These are examples of what are known as column vectors, and hopefully you will have come across these in transformations of shapes. So if it is in the context of transforming a shape in some way or another, the top part tells you how much to move it forward or backwards, in other words the X direction. The bottom number tells you how much to move it up or down, the Y direction. Here I'm just going to show you how simple it is to actually do three different things with these column vectors, starting with adding them. So literally you just add the X parts together, so that will be 5, and the Y parts together, which will be 12, and hey presto, you have this new vector. Okay, so the first one could be a line doing this, the second one would be a line doing this, and the result that you've got is the line doing this. Okay, just to put it into some visual context. But in terms of the actual number crunching, it's really very simple, as I've just said. So you won't be surprised to see that this takeaway one works exactly the same. So 7 take away 3 is 4, 4 take away 2 is 2, and there's our resultant vector. Third example here is an example of when we're going to scale up a vector. So this should remind you of algebra and brackets, and you're going to treat it exactly the same way. Namely, that 3 is going to multiply what's inside the brackets. So we'll have 3 6's, which is 18, and 3 minus 2's, which is minus 6. And again, just to give you a bit of a visual, so in terms of what this would look like if we were doing a diagram, so the original 6 minus 2 vector might be that, and then the 18 minus 6 vector is simply 3 times as long, but in the same direction. Now we're going to look at a fairly typical type of vector question, which involves some geometry, some shape work as well. So before we jump into that, I need to talk about some terminology. So you'll see over here that I've got OA in capitals with a little arrow over the top. That's one way to indicate that we're talking about a vector. In this case, it will be the vector that goes from O to A. So it's this little section here on the diagram. Another way of writing that is to write little letters but in bold, which is a bit difficult for me to show you bold on here, but that's what it would look like if it was typed. It would be a bold type. So what we've been told is that the vector between O and A here in capitals has a value of A. We've also been told that we've got a vector going from O to B, and that one is B. What the question asks us is to find out other vectors on this diagram using just those two that we've got to start with. So the first one that they want us to do is OC. So what we've got to do is link OC, the vector OC, to the vectors that we've been given, OA and OB. And OC, I think you can see, is fairly straightforward. It's just a longer version of OA. Now I'm telling you that this diagram's all supposed to be symmetrical, and so A is the midpoint of OC, so that means that OC will just be twice as big as OA, and it will be 2A. Next they ask us for OD. So we're going to have to do a little bit more work for this one, because that's not straightforwardly a longer version of either OA or OB. So basically the concept is you've got to get from O to D, but the long way round. So there's more than one way that you can do it. I'm going to do it by going from O to B, then I'm going to go from B to D. Now we already know that the vector going from O to B is just B. Now hopefully what you can see on this diagram is that B to D is the same as O to A. It's the same length and it's going in the same direction because these are parallel lines on this diagram. And so going from B to D is actually just the same as going from O to A, and so that's A. Now conventionally we write things in alphabetical order, so I'll just turn that around. So the last one that they want us to do is OG. Again, I've just got to find a path that's going to get me from O to G. So I'm going to choose this time to go from O to F, then from F to G. So O to F, B is it halfway between O and F, and therefore O to F is just twice as big as OB, so that's an easy one, that's just 2B. Then FG is the same as BD, which was the same as OA, so that's just an A on the end there, and then if we just turn that around, get our vector OG. Different diagrams, same kind of ideas. So we've been told again that O to A is worth A, if you like. O to B is B. What do we need to find? We need to find first of all O to M. How does O to M connect with either O to A or O to B? So we can see it's M is on OA. Now M, I'm telling you, is the midpoint of O to A, and therefore in this case it's going to be a half A. So next they're asking us for O to N. So what path could we take here? So let's go from O to B, and we want to go from B to N. So the O to B bit's straightforward, that's B. The B to N isn't straightforward because I don't know B to A. I don't know what that vector is. So I need to go away and work out what that vector is, and then I can halve it because N is halfway along B to A, and then I'll be able to find my B to N. So we now need to go back a step and we need to find B to A as a vector. How am I going to do that? I'm going to go from B to O, and I'm going to go from O to A. Now B to O is different from O to B because it's a different direction. So instead of being B, it's going to be minus B. But O to A is straightforward, that's an A, and then turning that all around we've got A minus B. So remember B to N is just half of that, so that means we've got plus a half A minus a half B here. That means if we tidy all of that up, we're going to have a half A plus a half B. So new diagram, same old OA, OB given to us as before. We've been told, however, in this case that n is not halfway along AB, but we've been given a ratio which will allow us to work out how far along AB n is. Ultimately, what they've asked us to work out is what mn is. So let's just first of all think about how we would get from m to n. So I'm going to suggest that we go from M to O. Then we're going to go from O to B. Then finally from B to N. Now, M is the midpoint of OA. So it's halfway along, but it's the wrong way round. OM would be the same direction as OA, but MO is reversed. So that means that that part is going to be a half, but it's going to be minus a half A. OB is simple, that's going to be a B. So the bit that we don't have again this time is the BN, because we don't have BA as our vector. So let's work that out again. So BA, B to A, going to be B to O plus O to A. B to O is the reverse of O to B, so that's minus B. O to A is plus A, so that's A minus B. So having worked out the vector BA, we've now got to work out the vector B to N, using that ratio that we were given at the top. So we're told that AN to NB is 3 to 1. Like our total vector, if we want to think about it in that way, is BA. That is worth A minus B. How many parts have we got altogether? We've got 4 parts, if you like, that make up the total line. So only one of those parts is NB. Therefore, NB is 1/4 of this A minus B. So if we put that in up here, we've got plus 1/4 A minus 1/4 B. So let's tidy that up, see what we've got. So we've got minus 1/2 A plus 1/4 A. So that means overall we've got minus 1/4 A. And then we've got plus B minus 1/4 B. So that means that we've got 3/4 B. So M to N, our vector M to N, is minus 1/4 A plus 3/4 B. And B to N is half of that. So if I add this in up here, we're going to have plus 1/2 A minus 1/2 B. And if we tidy all of that up, you can see we've got minus 1/2 A and plus 1/2 A, so they cancel each other out. And then we've got B minus 1/2 B, so that leaves us with 1/2 B. Now that's also showing something interesting here. So MN is 1/2 B. In other words, it's half the length of OB, but it's also the same orientation, the same direction. Another way of saying that is noticing therefore that MN and OB are parallel because they're in the same direction. That's what parallel is all about.